All right, we are doing the last day of 7B. Thank God. This is solving systems of inequalities. All right, so a system of inequalities is very similar to a system of equations, okay? The only difference is with inequalities, you have these either dashed or solid lines, and then they also get shaded. So like, let's say this line is shaded below it, and this line is shaded to the left of it. The overlap right here would be the solution. So any point in that area or on a solid line, not a dashed line, any point on a solid line would be a solution. So basically anything in here, okay, but not on the dashed line. All right, so when you graph, there are some things to remember with an inequality. You have to know what type of line that's getting graphed, either it's dashed or it's solid. And you have to know which direction to shade, either above or below, because we're always looking at y. So when we're talking about y, we're talking about on the y-axis, do we go above where the line is or below where the line is? All right, so let's say that, and these are all if your variable is like that, is on the left side. So if y is less than, means that the line is dashed because there's no symbol like this underneath. If it was less than or equal to, it would be solid. But if it's less than, then it's dashed. And it's also shaded below the line because y is less than whatever the is on the other side. If it's less than or equal to, it's solid and shaded below the line. So you can see the direction dictates which way you're shading. The type of inequality dictates the type of line. So if y is greater than, it's dashed, and we shade above the line. And if it's greater than or equal to, it's solid, and we shade above the line. All right, so let's look at this. Okay, so first things first, I give you the harder ones first. These, again, like with graphing, y needs to be by itself and be positive. Okay, so that means we need to get this completely by itself. So everything else that's part of the inequality on this side needs to make its way over to here. So let's start off by, you always want to add or subtract first. So we're going to subtract 3x from both sides. And again, you want your x and the coefficient of it as close to the inequality when you rewrite it as possible. So we get negative y is greater than negative 3x plus 7. Now I said that this y has to be alone and positive. So we've got this negative symbol we have to get rid of. So we can just go ahead and like basically change all the signs of everything in there. But, and this is important, when you have an inequality there and you're changing the signs, you're multiplying or dividing by a negative, the sign flips. So notice that this became that. So you should remember that from last semester, but if you don't, here's your refresher. If you multiply or divide by a negative, the sign flips. Adding or subtracting doesn't matter. So we would start at negative 7 because that's your y-intercept. So we start here at negative 7. And then we go up 3 and right 1 because our slope is 3. So here's our slope. Here's our y-intercept. So we went up 3 and right 1 because it's y is less than, not less than or equal to, it's a dashed line. Because y is less than, we are going to shade below that line. So I'm going to kind of show you, even though the line looks like we'd be shading right or left, you look at the y-intercept and say, okay, I'm going to shade below. So that would be down here. All right, so for the next one, we have 2x plus y is greater than or equal to 3. So start off by, again, subtracting 2x. Since we have a positive 2x here, we want to subtract 2x, which is going to give us y is greater than or equal to negative 2x plus 3. So we don't need to worry about changing the sign because the y is positive. So we start up 3 and then we go down 2 and right 1. There's our other point, and it's a solid line. And because y is greater than, we are going to shade up above the line. Okay, now the solution would be any point in this area where the two overlap. Okay, so anything in this area would be a solution except on the dashed line. On the solid line would be okay, on the dashed line would not, but any other point inside of here, like I could pick right here, I could pick right here, these would all be solutions to both of these. All right, so let's try another example. So now the y's have coefficients. This is why I want you to write down all the examples. So start off again by subtracting 6x from both sides. Now you're going to have a negative 3y is greater than negative 6x minus or plus 15. So we need to get this negative 3 away from the y. So we divide everything by negative 3 because then this cancels out. And then you just simplify or reduce these. So it gives you y is positive 2x. Now notice the sign flipped because I divided by a negative. So that made that sign flip. Okay, negative and a negative make a positive. So 6 divided by 3 is 2. And then 15 divided by negative 3 is negative 5. So again, here's your slope. Here's your y-intercept. And because it's minus, we take the whole thing. So we start at negative 5. We go up 2 and right 1. And it's a dashed line. And we shade below the line because its y is less than. Now over here, again, start by subtracting 2x from both sides. You'll get 6y is greater than negative 2x plus 12. So like before, we're going to divide to get rid of this coefficient. This needs to go away. So we divide everything by negative 6 because that cancels out then. Negative 2 over 6 is going to be a negative 1/3, and 12 divided by 6 is 2. Because remember, we're dividing everything by this. Everything. So you get y is greater than, and because we were dividing by positive 6, the sign doesn't change. Negative 1/3 x plus 2. So we can go ahead and we're going to start at a positive 2, and we're going to go down 1 and right 3. That's going to be our other point. And it's also going to be a dashed line because it is just greater than, not greater than or equal to. But now we're going to shade above. So again, our solution would be anything in this area here. Okay? Last example. These are already in slope-intercept form, so we're good. So all we need to do is say, well, this is going to be my y-intercept. So that's where I'm going to start at. And my slope is a negative 3. And remember, if it's a whole number, that's like saying negative 3 over 1. So that's how many you go up or down. And that's how many you go right. Okay, so because it's negative, we're going to go down because of this. So we're going to go down 3 and over 1. And it's a dashed line. Now for this one, we're going to start, and we should shade above the line, of course, because its y is greater than. Now for this one, we start at positive 3 because that's our y-intercept. It's the number that has no variable. So that's how you know that's the y-intercept. And now we have a positive 1 and a positive 2. So we're going to go up 1 and right 2. There's your other point. This is going to be a solid line because of this. So that tells you that it's solid. This tells you dashed. Okay, and this is facing away from the y, so we're going to shade below the line. Oh, I accidentally shaded above. Scratch that. Should be shaded below. Let's see if I can fix this. Let's do a highlighter, and let's do it in red. So all this should be shaded. All right, and you'll see the area that's kind of like darker. This area that I'm shading now. That's the solution. I know it's a little bit harder to see on here, but you get the idea. So the solution is going to be in this area right here. So all this is the solution. Okay? Everything in here. All right, so ignore that. Tips. Okay, remember, just in case, let's say your y ended up on the right side for whatever. If the inequality opens towards the variable, it's greater than, which means you shade above the line. If it faces away from the variable, it's less than, and you should shade down. So it kind of makes sense when you think about it, when you think about just the y-axis. The numbers get bigger going up and smaller going below. All right, and then do not forget that your solutions are in the shaded areas that overlap only. So the solutions to the system is only where the two areas overlap and not on the dashed line, but yes, on the solid line. Okay, that's it for you. Have a good one. Enjoy your day off.